Good afternoon, students. Welcome to the second lecture in the Embedded System Design course. So, in this, we'll be studying about Introduction to Embedded System, that is Unit 1. So, the topics which are present in this Unit 1 are Definition to Embedded Systems versus General Computing Systems, History of Embedded Systems, Classification of Embedded Systems, Major application areas of embedded systems, purpose of embedded systems, characteristics of embedded systems, and quality attributes of embedded system. So in this lecture, we'll be just try to see definition and the comparison of general computing systems and embedded systems, history of embedded systems, and also classification of embedded systems. And other four topics we'll try to see in the next series of lectures. So coming to the first topic, that is definition of embedded system. So we need to define the embedded system. So before defining, just we'll see what are the different devices which you will be seeing in your daily life, uh, which can be called as an embedded system. So one such is a washing machine. You can consider microwave oven, you can consider the mobile phone. All these are nothing but embedded systems. So we'll take washing machine as an example and we'll try to define what is an embedded system. So coming to washing machine, so just having an overlook of washing machine, you can find a panel on the top, so where you can set different types of wash modes, different options like um, rinse, wash, and also you can set different types of clothes also. So that is the panel. You can say that that is some electronic part. There is an electronic part in the washing machine, and you can also find a tub where you will be finding a rotor, so which can rotate the cloths. So that is the rotor part, or we can say a mechanical unit is there in the washing machine. So by taking this two into the consideration, so you can say that an embedded system is a electromechanical device. Electromechanical device. Why? Because it consists of some electronic components as well as some mechanical components. And one more thing is that uh, the software which is used for washing machine, there may be some software used for the washing machine, so that may not be applicable for other one like microwave oven or mobile. So that is different. And even the hardware which is being used for washing machine is different from the different embedded systems like a microwave oven or a mobile phone. So by taking all this into consideration, one is it may consist of electronic components, it may consist of mechanical components, it consists of specific hardware, and specific software. So by seeing all this, so we can go to the definition. So here is the definition. An electronic or electromechanical system which is designed to perform a specific function and is a combination of both hardware and firmware, that is software. So as we have seen the example as washing machine, so it may be an electronic system or it may be an electromechanical system. So whatever the washing machine which we are considering is electromechanical system, and it is designed to perform a specific function. So as washing machine is meant only for washing the clothes, or you can take the microwave oven which is for heating the food items or keeping food items hot. So that is meant for specific function, and it consists of both hardware and software. Okay, so that is nothing but the definition of an embedded system. So different embedded systems, there are some examples uh, given here. That is electronic toys, mobile handsets, washing machines, air conditioners, automotive control units, set-top box, DVD players, etc. All these are examples of the embedded systems. So as we have already defined the embedded system, so we can just say in simple, the embedded systems are unique in character and behavior. So as you have seen in the definition, it performs a specific function only, so that it is unique in character as well as a behavior, and with a specialized hardware and software. So whatever the hardware meant for washing machine, we cannot use it for the other embedded system. So we can say that with specialized hardware and software. So that is the definition of an embedded system. And the second topic which we have is the embedded systems versus general computing systems. So general computing systems are the one which will perform variety of tasks. But coming to embedded system, they are specific in doing only some functions. So first we'll see the first difference. The first difference for the general purpose system. A general purpose system is a combination of generic hardware and general purpose operating system for executing a variety of applications. So you can consider a desktop or laptop as an example for general purpose system. So where we can do different things like writing a document, you can draw a picture using paint, and you can record some videos, and you can do some editing work. All that can be done. It performs variety of tasks. So that we say it as a general purpose system. And what it consists of is a general purpose operating system and a generic hardware. That means we may be using Intel processor, we may be using some RAM from Samsung or Hynix. So that may not be specific. We can use different RAM or different processor for that also. So that we can say general purpose system have generic hardware as well as the general purpose operating system. That means it may use a Windows operating system, it may use a Linux operating system like. And coming to the first point or first comparison with respect to embedded system is a system which is combination of special purpose hardware and embedded OS for executing a specific set of applications. So as I told earlier, the embedded system will be performing only specific set of applications, and it is a combination of specialized hardware. So as the example which we took, washing machine, so it consists of only the hardware which can perform washing of clothes, and it may have some embedded OS, or we can say a software, so which will be specific for that system itself. So that is the first comparison. And coming to the second comparison, in general purpose system, even that point came in the earlier difference also. It consists of general purpose operating system. And coming to embedded system, it may or may not contain an operating system for functioning. So for an embedded system may have an operating system or may not have an operating system. So if it does not have an operating system, there will be some piece of code, so which will be running on the embedded system to perform its specialized function. Next, coming to the third difference. So applications are alterable or programmable by user. Uh, that is in the general purpose system. That means we can install the program, we can change the operating system. All that is possible in the general purpose system. And next, coming to embedded system, the firmware of the embedded system is pre-programmed and is non-alterable by end user. So user can't change the program of a washing machine. So they are pre-programmed already, and we'll be getting the product as a whole. So we can't modify anything in that. That means at user point of view or end user point of view. But there may be some exceptions. So where there is some specialized hardware settings we need to look into. Next, coming to the fourth difference. The fourth difference. So whenever you need to purchase an general purpose system, or whenever you need to take an general purpose system, you will be seeing mostly the performance for choosing that. Okay, or we can say for selection of the system. Always the faster is a better one. So faster means the performance point we will be looking into. That means for a desktop or a laptop, we'll also always see the performance for purchasing it. Next, coming to the embedded system. So it may depend upon the other factors also. So you may not only look into performance, you may even see the other requirements like power requirements, memory usage. So these need to be considered when we are taking an embedded system. And next, coming to the fifth difference. So less or not at all tailored towards reducing operating power requirement options for different levels of power management. So that means we don't have some power management. So you may be having to some extent in the laptop, but in desktops we don't have any power management uh, levels. So that means whatever the operating system we are using, so that is not specific to power requirements, or that means that that cannot have different levels to manage the power. So that is in the general purpose system. Coming to the embedded system, highly tailored to take advantage of power saving mode supported by hardware and operating system. So here the embedded systems may run with the battery power, or it may have uh, a supply, an external supply. So if it is running on the battery, it need to use the power saving mode. That means whenever the embedded system is idle, so it need to save the power. So that need to be taken care by the hardware and operating system. So embedded system will be taking the advantage of power saving modes, but we can't have that in the general purpose system. And coming to the sixth comparison, so response requirements are not time critical. So response requirements means if at all we need to get some response from the system, so it is not time critical. That means if suppose that if at all we require an output after 5 seconds, if at all we receive it 7 seconds or even 10 seconds also, that may not affect much. But coming to the embedded system, so for certain category of embedded systems like mission critical systems, the response time is highly critical. Means if at all the embedded system is used in launching a rocket, so every second is very much crucial. Or even in the hospital, there is in the medical equipment, if it is an embedded system, so every second is also crucial there also. So this uh, response should be time critical. That means you need to be considered as a time critical. It need to be in time. So coming to the last comparison, need not be deterministic in execution behavior for a general purpose system. So that means uh, deterministic means we will be able to define the time in which we can get the output. So execution means how much time it may take to complete the execution. So that we may or may not say in purpose of a general purpose system, and or it is not that important in a general purpose system. And next, coming to execution behavior in an embedded system. So it is even here also it is not that important for some types of systems, but if at all we consider some hard real-time systems. Hard real-time systems are the ones so where the deadlines need to be met in time. That means if at all if it is breaking the deadline, so it may cause a huge loss. So that execution behavior should be deterministic for the hard real-time system, that is for embedded systems. Next, coming to the next topic, we have history of embedded systems. So in the history of embedded systems, there may be many embedded systems even uh, in the olden days also, but the first recognized modern embedded system was Apollo Guidance Computer, that is AGC, so which was used by NASA. So this was used for a machine, so where it was built on with many number of ICs. Why? Because it was built during 1960s. So where we just had starting of the ICs. So in that time, so they used many number of ICs to build that Apollo guidance computer. And coming to the mass-produced embedded system, first mass-produced embedded system. So mass-produced means they are produced in large number. It is Autonetics D17 guidance computer. So this Autonetics D17 guidance computer is nothing but a machine control computer, that is missile control computer. So where this is used for launching the missiles. So this was used by the US military. So early users of the embedded systems are modern embedded systems were NASA and US military. And coming to the next topic, we have classification of embedded systems. So there are four categories under which embedded systems can be classified. So one is based on generation, and other one is based on complexity and performance requirements. The third one is based on deterministic behavior, and the last one is nothing but based on triggering. So we'll be seeing about these two, that is based on generation and based on complexity and performance requirements. So first classification, that is based on generation. So we have first generation, second generation, third generation, and fourth generation. So in the first generation, we have early embedded systems which were built on 8-bit microprocessors like 8085 and Z80. These are nothing but 8-bit microcontrollers. And even also they were built using 4-bit microcontrollers also. And next, coming to the second generation, so here we have the 16-bit microcontrollers or microprocessors. So that process the systems embedded system which were built around 16-bit microprocessors or 8 or 16-bit microcontrollers were used in the second generation, which followed the first generation. Coming to the third one, so we have embedded systems. So here we got high performance 16 or 32-bit microcontrollers or microprocessors. And here we have also an advantage of application specific instruction set process. It means like DSP, digital signal process. So where they use a specific set of instruction set to perform the signal processing tasks. And also we have application specific integrated circuits, so which are meant for some specific application. That means the instructions are being included to perform that specific application. So that is application specific. So all these were used in the third generation. We have 16-bit as well as 32-bit microprocessor microcontrollers is with high performance. As well, we have application specific instruction set process like DSPs and application specific integrated circuit, that is ASICs. And coming to the fourth generation, so we have system on chips and reconfigurable process and multi-core process. So multi-core process are nothing but so whatever in the systems which we are using with 8 cores, 4 cores. So all these are nothing but multi-core process. And reconfigurable process means so you'll be using FPGAs, field programmable gate arrays, complex programmable logic devices. So they can be programmed as per our requirements. So that is reconfigurable process. And system on chip. So these are nothing but ARM boards or any other system on chip boards. So these are being used in the the fourth generation. That is, embedded system were built on these, that is system on chips, reconfigurable process, and multi-core process. So this is based on generation, classification based on generation. And next we have classification based on complexity and performance. So based on the complexity and performance, we have three categories. It is small scale, medium scale, and large scale or complex scale. So small scale is the one which was built on there is 8-bit and 4-bit microcontroller. That is 8-bit process like 8085 or Z80 and a 4-bit microcontroller. This is same as what we have seen in the generation, that is first generation. And coming to the second one, we have medium scale. So where the embedded systems were built on 16-bit microprocessors and 8-bit and 16-bit microcontrollers. So which is comparable with the second generation, that is classification based on generation. The second generation we can take it as, we can consider it as the medium scale. Coming to the third category, that is large scale or complex category. So you can consider here the third category and even the fourth category also, that is fourth generation, third generation and fourth generation are comparable to the large scale or complex. So this is embedded systems which are built around high performance 16 or 30-bit microprocessor controllers, and also we can consider the application specific instruction process like DSPs and application specific integrated circuits also. You can even consider the others, that is which are being used in the fourth generation, that is system on chips or reconfigurable process or multi-core process also in this one. And in the next session we'll be seeing more about the applications where we can use the embedded